All right, so here in part 2 on the back of 10.1's notes, we're going to use a graph to help us solve a system of equations. So on the front, we were given some points and we tested them to see if they were solutions to the system, and if they were, they worked in both equations, not just one. And for most of these, there's either going to be no solution at all that works, these lines never cross, and we'll see what that looks like, or more likely, there's only going to be one specific solution. Because remember, these equations form lines on your graph. And most of the time, lines only hit in one spot. They're going to cross once, and then they both go their separate ways forever. So for most of these, there's just one single solution. All right, so we're going to take these two, and we're going to graph them, and we're going to see where do they cross. Remember that the lines on the graph represent every single solution. Every point on those lines is a solution for that specific single equation. And so if they cross that one spot that they share, that point is the solution that works for both equations. So all we have to do is put these on the graph and see where they cross. It's actually pretty easy. So if we have this equation, y equals x, I want you to think about what the slope is, what the y-intercept is. So the slope's whatever's in front of x. There's actually a 1 there. So the slope is 1, which is the same as 1 over 1. So we're going to be going up 1 over 1. And our y-intercept, I don't have a plus or a minus, which means that my intercept is 0. So if I go over here to put this line on the graph, I'm starting at the y-intercept of 0, which is the origin right in the middle. And I'm going to use my slope of up 1 over 1. And my line's going to look like this. Now, because we're trying to find one very specific point that these cross, we can't just draw a quick line and not have it actually be straight and follow everything. So if you want to use a straight edge, that's fine. Or draw every point that you can and make sure that this line hits all those points. Because we don't know where this next line is going to cross this one, or if it is at all. And so if you just draw it and your line happens to curve off, and that's where they're supposed to cross, then you're not going to be able to see the point that you need to see. All right, starting with the next one. So we have 4x minus 2y equals 12. We want to put this one on the graph, right? And so we can't do that until this is in nice y equals form. We just kind of tested on that, and that's why we're doing this after chapter 6. So we want to get this into y equals everything else, y equals mx plus b form. It's going to make our life easy, giving us the slope and intercept. So first thing I'm going to do is I'm going to move this x away from y. So I have negative 2y. I'm going to put the x in front. So negative 4x, 12 is positive, plus 12. Get rid of this negative 2 by dividing everything by negative 2. It's not an inequality, so I don't have to worry about flipping anything. So y equals, 2 negatives make a positive. 4 divided by 2 is 2. And a positive and a negative make a negative, so I write minus. 12 divided by 2 is 6. Okay, so my slope is 2, which is 2 over 1, up 2 over 1. My y-intercept, minus 6, is negative 6. So that's where it's going to hit the x-axis. And so if I go to, the y-axis, negative 6. So if I go to negative 6 on the y-axis, that's where this line starts. Always start at your intercept. And then use your slope to draw the rest of the line until it hits this one. Okay, so it's going to go up 2 over 1 because the slope is 2. Up 2 over 1, up 2 over 1. You can see it's not going to hit it for a while. Up 2 over 1, up 2 over 1, up 2 over 1. And it doesn't hit until right here. So you can draw that line, really focusing on where it's going to cross. Now you're not done. We need to actually identify the solution. So what point is this? Okay, and so the x value is 6. And the y value is also 6. So that point that they cross is 6, 6. There's only one solution here because it's the only one spot that they cross. That solution is 6, 6. And just like we did on the front, if we took this now and we went back and plugged it into both equations, it would work on both sides. You'd plug it in here, you'd plug it in here, 6 and 6. You'd get 12 on both sides. If you put 6 and 6, you get that. And any other point that you see on either one of these lines, it's only going to work for that line, not the other one. The only point that satisfies this system of equations is 0.66. It's the only x and y value that will work. Okay, so let's look at some different situations. Now that's your standard one that's going to cross once. Here's a different one. So if I have y equals negative x plus 4, my slope is negative 1. That's negative 1 over 1. So that's down 1 over 1, down 1 over 1. And my y-intercept is 4. So I'm starting at 4. That's where it hits the y-axis. And now I'm going to use this slope of negative 1, 1. So down 1 over 1, down 1 over 1, all the way across this graph. So it looks like this. And let's see what happens with the other one. So y equals negative x minus 2. What do you notice right away? The slope is also negative 1, which means when the slope is the same, it's going to move across the graph in the same way. It's going to go down 1 over 1, down 1 over 1, down 1 over 1. And so if they're both going down at the same rate, that tells you something. Okay, we'll take a look at it in a second. Y-intercept is negative 2. So we're going to start at negative 2 on the y-axis. That's your y-intercept. And we're going to use our slope. Down 1 over 1. Over and over and over. And if you can start to visualize this, if it is going down at the same rate as the other line, if the slope is the same on both of your lines, they're going to run exactly the same, and they are never going to cross. So there is no solution here. These two lines are parallel, and so it's important to understand same slope means parallel, right? Because they're going to run down or up, whatever it is, the same amount, so they're never going to cross. They're going to run side by side if they have the same slope. Now there's one more special solution. Okay, I want to look at it on the last one. So starting with y equals 2x minus 5, that's in beautiful form. So our slope is 2. Our y-intercept is negative 5. So let's throw that on the graph real quick. We're starting at negative 5. Slope's positive 2, which is 2 over 1, up 2 over 1. Okay. And now the other one, we got to do a little bit of work too. It's not in good form. So we got to get y by itself, move the x first. So I have negative 3y. I'm going to put the x up front, negative 6x, positive 15. I put plus 15. Divide by the negative 3 all the way across the board. So y equals, 2 negatives make a positive. 6 divided by 3 is 2. Positive and a negative make a negative, so I'm going to put minus. 5 divided by 3 is 5. My slope is 2. So right away, look, I've got the same slope. So your first instinct might be to say, oh, there's no solution because they have the same slope. They're going to run the same direction. They're never going to touch. But take a look. The y-intercept is exactly the same as the y-intercept here. These are actually equivalent equations. So when I go to put this one on the graph, I'm going to start at my intercept of negative 5. And I'm going to use my slope up 2 over 1, up 2 over 1. And every single point is going to fall on this line. So any point that's on this line is also going to be on this line. And you might say, well, it's just the same equation. So this isn't really a system, right? They're the same equation. They're not different. But in a real story problem, these may represent different things. Okay, and that's why they're written differently. But we come to find out that they actually have the same set of solutions. And so what we're going to say is there is an infinite number of solutions. Now, what you can't go and say is you can't go and say all real numbers. Now, we use that a lot before, but we can't say all real numbers because there's numbers out here that are not going to be the solution. Okay, so infinite solutions is the proper term that we're going to use.